I'm Anil Kumar, sharing with you a very interesting question on indeterminate powers. We'll use L'Hopital's rule to find the limit. The question here is, find limit as x approaches pi by 2 from the left side, that is minus tan x to the power of cos x. Now, what is tan of pi by 2? Tan of pi by 2 is infinity. And how about cos of pi by 2? Cos of pi by 2 is 0, right? So we have a form which is infinity to the power of 0. So that is an indeterminate power. And here L'Hopital's rule can be applied, right? Now in such cases, the idea is to always write the function as an exponential function, e to the power of something, or we can use natural log. So these are the two strategies which can be followed at this time. I'll prefer to write this as with y equals to, let me rewrite this as y equals to tan x to the power of cos x. So I'll write this as y equals to tan x to the power of cos x, and taking natural log on both sides, we can get ln y equals to cos of x times ln tan of x. Now we need to find the limit of this, so we can say limit as x approaches pi by 2 from negative side for y equals to limit as x approaches pi by 2 from negative side, that is the left side. Now you have seen that whenever we try to use L'Hopital's rule, we have to write this as a quotient of two functions. In such cases, it is preferred to write, ln tan x always in the numerator. So don't take this in the denominator. However, cos x could be taken in the denominator. You could write this as secant x, right? You could do this, write cos x as secant x, 1 over cos x. Or let me write 1 over cos x. Okay. But at this stage, you could also write ln tan x over secant x. Now, if I write pi by 2, then we know tan pi by 2 is infinity, cos pi by 2 is 0, 1 over 0 is infinity. So we have indeterminate form infinity over infinity, right? So this is of the form infinity over infinity. So we can again apply the L'Hopital's rule. So that is, we'll take the derivatives of both numerator and denominator. Limit for the quotient of functions is same as limit for quotient of their derivatives. That's the whole idea, right? So we get limit x approaches pi by 2 from left side. Derivative of ln tan x will be 1 over tan x times derivative of tan x, which is secant square x. Now in the denominator, you could write derivative of secant x, which is secant x tan x, or you can apply the quotient rule. So I'll apply the quotient rule. So we'll get denominator as cos square x, and derivative of cos x is minus sin x, and minus becomes plus, so we get plus sin x, right? So we could write this in this form also, either way. Now at this stage, I will convert all these in terms of sine and cosine and then simplify. So what we have here is limit x approaches pi by 2 from left side. Now tan x, 1 over tan x, could be written as tan is sine. So I'll write sine x over cos x. Do you see that? So, or cos x over sin x. Secant square x is 1 over cos square x. In the denominator, we have sin x over cos square x. So in the numerator, we could write this as cos square x over sin x, right? So we get a very simplified expression, trigonometric ratios. Now you can cancel whatever you can. So what do you get? Let's continue on the right side. So So what we get here is limit x approaches pi by 2 from the left side is equal to of y is equal to limit x approaches pi by 2 from the left side. We have cos x over sine square x. You see, cos x over sine square x. This is what we get. So we get this is cos x over sine square x. Now, if I substitute pi by 2, what do I get? Cos pi by 2, let me write here, or doesn't matter, we'll write here. Okay, so what we get here is cos pi by 2 over sine square pi by 2, right? Now cos pi by 2 is 0, so we get 0 over sine square pi by 2 is 1. So we get 0 over 1, so that gives us 0. So the limit of y, which was defined as tan x to the power of cosine x, is actually equals to 0, right? So that is what we have got. So from here, so what y is for us? Y is tan x to the power of cos x. Now actually, let me show you different ways of doing it. One, you could directly write from here that limit for, I'm sorry, it was ln y, okay, ln y, I missed ln, okay, limit of, let me correct it, limit of ln y. We took log both sides, right? Natural log, this step, so limit of ln y. So this stage, it was limit x approaches pi by 2 from the left side of ln y, right? So ln y. So basically, you know, you could write y as e to the power of ln y, correct? So let me show you why we normally write this as e to the power of 0 as the limit of this answer, right? Now, so the limit as x approaches, in our case, pi by 2 from the left side for y, y is tan x to the power of cos x, right? That is y, which we substituted, is equals to e to the power of limit x approaches pi by 2 of y, ln y, right? Of ln y, right? So this we found as e to the power of, so limit of ln y is 0, right? So it is e to the power of 0, and that gives you 1 as your answer, right? So therefore, the limit of the given function is, so we can write limit as x approaches pi by 2 from the left side for tan x to the power of cos x is equals to e to the power of 0, which is 1, right? So that is how you can answer. Well, some of you at this stage, when we have limit ln y is equals to 0, you could write this as limit for y is e to the power of 0, right? You could directly also write, but here is an explanation which helps you to understand why we get this answer, right? So that is how you could do this. This is very important question from test point of view. I'd like you to go through this solution, understand, and then do similar questions. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Thank you, and all the best.